Remember this, what does this operator do? It's asking us to find the tendency of this function when x approaches 1. So what is the first step? Anyone? What do we need to do first?
Plug 1 into the equation.
Absolutely. We have to. Why? Because I don't know if it's a simple situation, like you have the number and move on. I have a no hope, or I have something like this, which we do not know how to deal with yet. We will very soon. Okay? So is it this? I have trouble. Is it this simple number, or this one that is more complicated, but there is hope? Okay, so let's plug in and write on top of the equal symbol, what is the top? Where
3.
is it? Okay, so 1 plus 2 is 3 indeed. And the denominator?
0.
0. So the answer is trouble. Trouble, and the answer could be negative infinity, positive infinity, or DNE. Now, I realize that this limit is not as simple as this one. Why is it simple? Because it's only from the right. This one is from either side, which means I must 3 over 0. Must calculate two limits. The limit as x approaches 1 from the left of this function. You know, lazy people don't want to write it again, like me. I'm kidding. And x approaches 1 from the right of this function. I cannot conclude. I cannot conclude before I determine the left-hand limit and the right-hand limit. What if I get that they're both infinity? What do I write here?
Does not exist.
Careful. If they're both infinity, what do I write here?
Infinity.
Infinity. What if I get that they are both negative infinity? What do I write here?
Negative infinity.
What if I get that one is positive and the other one is negative? What do I write then?
Does not exist.
Exactly. Awesome. You're paying attention. I'm very proud of you. Thank you. So why do I need to do this? Because the limit is from the either side. Not a simple one just from the right or just from the left. Because it's from either side, I don't know what to write. I have to investigate both limits. Okay, so limit as x approaches 1 from the left of x squared plus 2x. And I like to write this. Anyone remembers how to write that? That's your hint. For simplicity, I would like to change that. How do I change it?
Is it x squared minus 1?
Excellent, thank you very much. You mean x minus 1 squared. Good, okay, so the numerator doesn't change. The denominator doesn't change. But now please plug in from the left of 1, like 0.9. Immediately, don't say 0 or -5. You have to be very close to 1 from the left, and here with 1.1. We know the answer for the left and right limits, but we don't know the sign. So please plug in 0.9. I don't need any calculations. I only need the sign. Please plug in 1.1. I don't need any calculations. I want the sign.
Both positive.
Of course, because of this. That's why I factored. The numerator, no matter what, approaching 1 from either side, of course, is 3. It will always stay 3. and the denominator will always stay positive. So therefore, now I know that these two are both positive, and based on this, of course, I'm going to write that x equals 1 is a vertical asymptote immediately, but also I can draw the conclusion here. What is it?
Infinity?
That's it. That's it. So remember, when you have a limit from either side, you have to calculate both sides. You cannot draw a conclusion about that. Okay, one last question here that I like to work on. And I'm just going to choose now. So this is limit. We are given, so this is it here. We have limit as x approaches -1 from the left. They say of f of x is 0. Then limit of f of x is 1 when x approaches -1 from the right. Limit as x approaches 2 from either side of f of x is 3. And I'll show you in a moment what I'm copying. F of -1 is 2, and f of 2 is 1. And this is problem 17. So I'm just going to share my screen for a second. I'll come back. So I copied this problem. Limit of f of x as x approaches -1 from the left is 0. Limit of f of x as x approaches -1 from the right is 1. Limit from either side of 2 is 3. F of -1 is 2, f of 2 is 1, and they want sketch the graph of an example. Infinitely many answers here, correct answers. Sketch the graph of an example of a function f that satisfies all the given conditions. Okay. So if you ask me what this is, I'm going to say gibberish. That's all it is. But if I organize it correctly, it will speak to me. Right now is gibberish. Nothing. So I'm going to organize my work, my information, and then my work. I will start with the simple part. F of -1 is 2. So 0 is somewhere here. -1 is 2. This is done. 2 is somewhere here. F of 2 is 1. Done. Now, I'm looking at this. The limit as x approaches 2 from either side is 3. Ah. Aha. Those parentheses. The limit of f of x from either side of 2 is 3. Done. Now, the limit of f of x from the left of -1 is 0. Ah, okay, the parenthesis, done. The limit of f of x as x approaches -1 from the right, ah, it's 1. Yay! Now the gibberish is very clear. Very clear. All that means nothing to me. Aha! Now everything is super clear. So I will graph an example of a function that complies with the given conditions. No worries. I will start, of course, by plotting the points. -1, 2. Two, 1. The limit from the left of -1 is 0. The limit from right of -1 is 1. The limit from the left and right of 2 is 3. and that's my function. Here, -1, 2 is the full point. The limit from the left is 0. The limit from the right is 1. The limit from either side, of course, does not exist. The function value is 2. But the limit from either side does not exist because the left is 0 and the right is 1. Here, the limit from either side exists, is 3. The function value is 1. And that's my function. You can get creative, put a vertical asymptote here if that's what you want, and do this. Who cares? As long as the given conditions are fulfilled, you can get creative and do whatever you want. But this is an example of a function that fulfills the given conditions in the problem. Okay, we're not going to have, I know I'm looking at the time. I have, what do I have? 8 minutes. I'd like to start section 2.3. Of course, you're not going to have anything to do with it just yet. Limit laws. Limit laws. There are several limit laws, but first of all, we have to talk about conditions of applicability. So limit of f of x as x approaches a from either side. When I say this, it means that this is a number. The limit exists from either side. The limit from the left is L. The limit from the right is L. Another condition, limit of g of x, another function, as x approaches a, also exists. And let's say it's a number m. Okay. So limit laws, they come in so handy, and we apply them. We don't even talk about it, basically, to be honest. So here's number 1. The limit, so this is an operator that is really telling us where this function is going. This is a limit called the limit operator, which is basically tendency. Where's the tendency? To get to L. Where's the tendency? To get to M. So now the limit as x approaches a, and I'm going to write 2 limit laws together because it's, you know me, I'm lazy. Wild guess. So if I have the sum of these 2 functions and both limits exist, what will be the limit of the sum, or what will be the limit of the difference? Wild guess. What do you think?
The sum or difference of their limits?
Absolutely. Limit, thank you very much, as x approaches a, plus or minus, if this is plus, this is plus, if this is minus, of course, limit of g of x as x approaches a, and then eventually what will it equal to?
Is it L plus or minus M?
That's it. Awesome. Thank you very much. So if this limit doesn't exist, so I don't want you to think and say, oh, you're just distributing the limit operator. No, no, this is not a distributive law. Okay? So it looks like it, but it's not a distributive law. So the limit of a sum of 2 functions is the sum of the limits of those functions. The limit of the difference of 2 functions is the difference of those limits, as long as they exist. Okay, next one. I'm looking to see. Okay, I have 5 minutes. Okay, number 2. Limit as x approaches a from f of x times g of x. Wild guess. What do you think?
Is it going to be limit f of x times limit g of x?
That's it. And eventually this will be,
L times m?
that's it. Number 3, limit of f of x divided by g of x as x approaches a. Wild guess?
Is it also limit f of x divided by limit g of x?
Absolutely. And yes, it is L over M, but there is a big if here, which we did not have before. What is the big if?
G of x is not equal to 0.
Yes, this limit does not equal 0. So limit of g of x as x approaches a does not equal 0, because then this will not exist. Very good. Very good. Number 4, limit of a constant times a function as x approaches a. What do you think? Wild guess. Here's your hint.
Say c times limit of f of x.
So maybe I should write it like this so it's clear. Yes, c times the limit of f of x as x approaches a from either side, which will end up being c times L. Because we, from the beginning, our hypothesis says the limit is L. Okay. Number 5. The limit of a constant as x approaches a from either side. What do you think? Wild guess. Who cares where x is going? What is the limit of a constant? What is the limit of 5?
Constant.
Of course, of course. Who cares? Okay, very good. Limit as x approaches a from f of x raised to power n. N is a positive integer. This is something that I like to call the swapping of operators. This does something to this function. This also does something to this function. Which one I have to apply first is this. I have the function by the rule of the operations rule, the rule of the operations. I have to apply this first. And when I'm done, I can apply this. I'm going to swap them. So this is first and this is second. I'm going to make this first and this second. I am allowed only under continuity, conditions of continuity, which we don't know yet, is the next step. So I'll say limit of f of x as x approaches a. So what would that be? And this is, I'm going to stop right here. So what is this?
L.
Very good. Good.